Let's discuss question number 30 from test 5. This is from IC engines, so thermodynamics. Okay, so a 42 kilowatt engine, so that is the brake power. Generally when you specify, we just specify, if nothing is mentioned, it is just the brake power. Brake power engine has mechanical efficiency of 85%. So if the friction power is assumed to be constant, friction power, let us denote by Fp, is assumed to be constant with the load. Means if the load is changing, it will not change. So what is the mechanical efficiency at 60% of the load? Now 60% of the load, we need to find out load. So first, what is mechanical efficiency? Mechanical efficiency is brake power by indicative power. So it's basically, let's say the engine, the power at the engine at the cylinder level, it's IP, but then in between you have the losses in the bearings and other frictional, other places where you have friction, and finally you get is the brake power. So that ratio is what is captured in the mechanical efficiency, and IP is nothing but, we write IP as PP plus friction power. So in this problem, PP is given 42.5 and PP is 42.5. The friction power is something which I don't know. Mechanical efficiency is 85, so 0.85. So from this I can get frictional power, which comes out to be 7.5 from this. So 7.5 kilowatt is the frictional power. Now at 60% of the load, obviously when the load is reduced, load is like torque, and if I assume that everything moves at the same speed, because that is what is the assumption. So same speed, if I assume that everything is moving at the same speed, so obviously torque into speed is the brake power which you observe, and the load is reduced 60%, the torque is reduced by 60%, the entire brake power is reduced by 60%. So brake power will be 0.60 of 42.5. that is the new brake power. And now my mechanical efficiency will be the brake power by your indicative power, which is brake power plus friction power. Friction power is not changing with the load, so brake power is 0.6 into 42.5, and then 0.6 into 42.5 plus 7.5. so obviously the mechanical efficiency will increase. So let's say will decrease, because the denominator has decreased. So this value, if we calculate, this comes out to be 77.3%. So this is the mechanical efficiency. So the catchword here is 60% of the load, the torque is reduced at the same speed. That is the assumption. It's not given, but inherently it means that. And so the torque is reduced, so the brake power would be just 0.6, will be reduced by 60%. So first get the friction power, and then it will be used for the next calculation. So the answer for this is D. Thank you.